Welcome. This video is going to talk about solutions and a way to express solution concentration known as molarity. It's a common way to describe concentration quantitatively, so it's going to be a number and a calculation. It's also called molar concentration. It's abbreviated with a capital M, and you may remember that capital M is also used to represent molar mass. So you have to read the context of the problem to realize which one your capital M is representing. So capital M is found or represents moles of your solute over liters of your solvent or solution. So the label is going to be moles per liter, or you can abbreviate that MOL/L, or just capital M, but it's important you put one of those labels on your answer. And so the equation is just what it sounds like. Molarity equals moles of solute divided by liters of the solvent or solution. So here's an example. If you have a 100 milliliter sample of an aqueous solution that contains 6.5 grams of HCl, what's its molarity? Now this is a pretty common way that your information is given to you, that the solute is measured in mass, because often the solute is a solid, and the solvent may be measured in liters or milliliters, but usually as a volume. So your job is to make sure that you have the solute in moles and the solvent in liters. So my 6.5 grams of HCl, I need to change that to moles. So if I look HCl up, I should be able to find the molar mass for HCl. So using my periodic table, I see that potassium's 39.1, chlorine's 35.45. So this has a molar mass of 74.55 grams. So my 6.5 grams divided by the 74.55 means I have just 0.087 moles of HCl. And again, you can just leave this whole long decimal. You don't have to round off in your calculator, but for the sake of writing it down, I'm going to round to my 2 sig figs. So that's going to be on the top, 0.087. And now I have to change my 100 milliliters to liters. And after you change this a few times, you'll get much quicker at it. You'll remember that there's 1,000 milliliters in a liter, or you move your decimal place over 3 times. So this is really 0.100 liters. So now I have my moles and my liters. So if I take my 0.087 and divide by the 0.100, I come up with the molarity of 0.87, and I can just label it capital M or moles per liter. Another way this equation is used is telling you how to prepare a molar solution. I'm being asked how many grams of sucrose, and that's sucrose's formula, are needed to prepare 2.5 liters of a 1.5 molar solution. So again, I've got two of my 3 variables. I'm being asked to find the third one. So if I look at what I have, I'm being asked to come up with grams, which I will get from my moles. So I need to find X moles of sucrose for a 2.5 liter solution with a molarity of 1.50. So if I multiply both sides by 2.5, I find out that I'm talking about 3.75 moles of my sucrose, C12H22O11. So now that I know I have 3.75 moles of sucrose, I have to get out my periodic table. And this is a heavy one because I've got 12 carbon at 12.01 and 22 hydrogen, which are only 1.01, and 11 oxygen, which are 16. So I come up with the molar mass of 342.34 grams per mole. So that means 3.75 moles is going to be a fairly sizable amount. I come up with 1,284 if I round to 4 sig figs, or 1,280 if you round to 3 sig figs, and that is grams of sucrose. So here's one for you to try. So I'd encourage you to pause this before you watch my solution. What is the molarity of a solution that has 95 grams of magnesium chloride dissolved in 435 milliliters of water? So remember, I need moles, I need liters. So starting with my 95 grams, I need to know what the formula for magnesium chloride is. So since this is ionic, I need to know my oxidation numbers. So that helps me determine that would be MgCl2. So that means the molar mass of 1 mole is 95.21 grams. So this is right about 1 mole. I think even with sig figs, it's going to come out to rounding to just 1.997. So with my 2 sig figs, this could be considered 1 mole. But again, I'll just let the decimals ride my calculator. The 435 milliliters of water, again, if you don't remember, 1 liter is 1,000 milliliters. So this is going to be 0.435 liters. So 1 mole over 0.435 liters is going to be 2.3 moles per liter, or capital M. Here's one for you to try on preparing a molar solution. How would you prepare 100 milliliters of a 4.5 molar aqueous solution of NaOH? So remember, it's the moles you're missing. And this one doesn't specifically say you should have it in grams, but since it's asking how you would prepare, we don't have a way to measure out moles. So it's just expected that you will express your final answer in grams here. So big M is my moles per liter. So what I know is I want a 4.50 molar solution. I'm trying to figure out how many moles, or ultimately how many grams of NaOH that's going to be. And it's 100 milliliters. And once again, 100 milliliters means 1 liter is 1,000 milliliters. So this is really 0.100 liters. So that means we're really talking about 4.5 times 0.100, or 0.45 moles of NaOH. So my final step is to take that 0.45 moles of NaOH and convert it to grams. And Na weighs 23, with the oxygen and the hydrogen is going to be 40.01, right about 40 grams per mole, times the 0.45 moles. And I would need to dissolve 18 grams, 18.00, 18 grams of NaOH in my 100 milliliters of water. And that should give me a 4.5 molar solution. Another thing that's commonly used with molarity and concentration is a lot of acids and bases that we buy come already mixed up as a solution. So rather than having to measure out the solid, grams of the solid, it's actually already in a solution, but it's very concentrated. This is like when you buy concentrated juice. It could be frozen, like concentrated orange juice, and then you let it thaw out and mix it up with some water. Same type of idea, but we buy very concentrated solutions that we call stock solutions. So stock solution is just another word for concentrate solution. So then we dilute the solution down. So now rather than finding out how many moles or grams we need to use, we need to find out how many liters of our stock solution we need to come up with a diluted solution and X liters of that. So you add more solvent, usually it's water or alcohol that your stock solution is mixed in. And so the amount of solute doesn't change, but the molarity is going to change. You're watering it down, you're making it weaker. So it's like when your coffee is too strong and you add water to it. It makes more coffee, but the overall solution is more dilute. So let's look at an example of what I'm talking about here. What volume in milliliters of 2 molar calcium chloride stock solution would you use to make 0.5 liters of 0.3 molar calcium chloride solution? How much water would you use? So the equation we had on the previous page said that M1 times V1 should equal M2 times V2. And the reason for this is that my original stock solution molarity is going to be high, whereas the volume will be less, and when I get done, I'm going to increase the volume but decrease the molarity, so when I multiply them, it should be equal to what I started with. So I've got an M1 here of 2.00 moles. V1, I don't know what it is, and it doesn't matter if I call this V1 or V2. So what volume of 2 molar calcium chloride should I use to make 0.50 liters of 0.300 molar, get my decimal point in there so we don't forget it, of 0.5 liters. So I just have to move my 2 to the other side by dividing. And when I plug and chug here, the 0.3 times 0.5 and divide by the 2, I only need to use 0.075 liters, or a lot of times we change this to milliliters because 75 milliliters is a little easier to understand. But we can just leave our final answer of 0.075 liters of the stock solution, or the 2 molar. My second question says, how much water would I use? And some of you go, well, how the heck would I know how much water to use? Well, actually, this is the easiest part of the equation. We said we're going to make 0.50 liters total of my new solution. And in order to make the new solution, I have to take some of my concentrated stuff, and just like when you take concentrated orange juice, the way you make your diluted orange juice is you add some water to it. So I have to add water to it. How much water do I add? Well, if I want 0.50 liters total, and I know that 0.75 liters is my stock solution, I just need to subtract these two to come up with the amount of water I should be adding. So when I subtract these, that means I should be adding 0.425 liters of water. So now I know how much stock, how much concentrate, how much water, and together they will give me my 0.50 liters. So here's one for you to try. You have 18 molar stock solution of HCl, and if that sounds really strong, it's because it is very dangerous. Your experiment only calls for 125 milliliters of 3 molar HCl. So I want to know how much stock solution and how much water should you mix together to get this 125 milliliters of 3 molar solution. So I encourage you to pause and try this on your own. Remember, we're using M1 times V1 equals M2 times V2. So my stock solution is 18 molar. I don't know how much of that I'm going to need, but my final solution should be 3 molar and 125 milliliters. Now technically, molarity is given in moles per liter, but you could just as easily change that to moles per milliliter. So there's no need for me to change this to liters. I can just leave it as milliliters, as long as I know that means my other volume will also be expressed in milliliters. So solving for X, I'm going to take 3 times 125 divided by 18, and that means X is 20.8 milliliters. That's how much stock solution I use. Not very much. So how much water do I use? Well, that would be the 125 milliliters of total solution I want, minus the 20.8, or you can round this to 21, just 2 sig figs. That means 104 milliliters should be water, because my 104 and my 21 will give me a total of 125 milliliters.